And now some solved problems for chapter 22. So here we have a magnetic field that's going to be equal to 10.5 times 10 to the negative 9th Tesla. That's what that nano means. And that's going to be equal to the magnetic field strength. Essentially what we have is we have an electromagnetic wave. We'll just kind of picture the electric field going up and down. Picture the magnetic field coming into the page and out of the page. And so, kind of like that. Make sure I draw these guys like this, and it's going to be propagating in that direction right there. Now this is the way that it's typically written. However, the way that it's typically drawn. However, one thing to keep in mind is not related to scale. Essentially, we can say that the electric field strength must be equal to the speed of light multiplied by the magnetic field strength. And so, this is what we're looking for. We're looking for the field strength of the electric field. So it's going to be simply the speed of light, c, 3 times 10 to the 8th, multiplied by the magnetic field strength, 10.5 times 10 to the negative 9th Tesla. And we're going to get a field strength of 3.15 volts per meter. And what that kind of says is this is definitely not to scale. The electric field is much, much, much stronger than the magnetic field. Now, if we have an electromagnetic wave given some frequency, we can find its wavelength quite simply. Remember that the speed of light must be equal to the wavelength multiplied by the frequency. So here I'm looking for the wavelength. That's simply going to be the speed of light divided by the frequency. So 3 times 10 to the 8th meters per second divided by 7.14 times 10 to the 14 hertz. It's going to give me 4.2 times 10 to the negative 7th meters, or 420 nanometers. Go ahead and take a look at a spectrum, and you're going to see this is actually going to be in the visible light, and it's going to be the color violet. And some more practices calculating wavelengths and frequencies. So I'm given some frequency, and I'm looking for the wavelength. Cell phone is going to be electromagnetic wave, so it's going to travel at the speed of light. So much like in the last example, wavelength was going to be equal to the speed of light divided by the frequency, or 3 times 10 to the 8th meters per second, divided by 1.9 times 10 to the 9th hertz, and I get a wavelength of 0.16 meters.